All right, can you hear me? Yes. Thank you for coming. Welcome, everybody. Thanks for making it right after the lunch. I hope you're not falling asleep, and I hope this presentation keeps you awake. Let's start with introductions. My name is Sebas. I come from the south. I'm Spanish, but I live in the north, in Amsterdam, in the Netherlands. And I work for this company called Q42, which we make apps, websites, AI, digital products in general, and we work for other clients building applications. So for the last year or so, I have been working on this project, building a library with Compose. For this application, the McDonald's application, you know, the burgers, not the ones with the crown, the one with the clown. And so if you want to make jokes about it, today is your lucky chance, but right after the presentation, because today is everything about Compose. So let's get started. And I will start with this statement. I think Compose is awesome. The design of Compose is really good, especially if you come from the old view system and you transition to Compose, you probably realize and feel like, oh, it's so much better. Because the internals of Compose are kind of full of magic and complexity everywhere, but it's also elegant and kind of awesome that you have simple APIs to build complex things. So it's quite minimalistic, and I really like that. But of course, with magic, you will think, oh, I come to this talk and Sebas is going to demystify all the magic. I'm going to explain you all the performance things. I'm sorry to tell you right away, that is out of the scope of this talk, because that will literally take a whole book to explain all the internals of Compose. So here is a shout out to Jorge Castillo, has this amazing book called Jetpack Compose Internals. And it's a really good one. I'm really thankful because with that book, I could understand a lot of the magic that goes internally in Compose and how the compiler works behind the curtains. So it's really good. But full disclaimer, I still think it's very complex. It's just not magic anymore for me. So well, with all this magic of Compose, does the magic trick always work? Is everything solved out of the box? Well, of course not. There is always limits to the things that Compose can pull off. And today, we're going to go through some of the examples of my real work experience with concrete things that, yeah, sometimes didn't work, and then the magic crumbled, and what we did to fix it. So maybe we can start with this question, like, should I worry about performance? It's like, yeah, well, no, yes, you should worry for sure. No, I mean, Sebas just said that everything is magic, no? Or, oh, no, wait, sometimes it fails. So I don't know. To be honest, I don't think you should worry. I think you should all care about performance. So caring about performance is very important, but you should try to avoid worrying, and especially the kind of worry that leads you to premature optimizations, because you start fixing things that you don't even know if they are problems. So maybe we can rephrase this to something different and start with the question of, what is the performance of my app? Do I have problems that I have to take care of? And then you can start avoiding this premature optimization and focus on real problems based on real feedback. Where can we start? Well, luckily enough, we have our dear friend Android Studio with a layout inspector that I hope all of you have ever opened. And if you have seen since quite some time, when you analyze the layout of your composables, you will see some nice counters on the side that will tell you, well, what is the recomposition count? Quite a quick tip first, maybe you don't see those counters. And this is something that really happened to us, because the Android Studio requires some file, compose blah 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 .version file that is shipped in your APK, just to know what is the version of Compose that you're using. If you decide to delete this file or not exclude it from the packages, like we did in this commit, well, this is the fix, but the one on the left was the original code. Well, you're not including this, and you will probably see an error saying, Compose inspection is not available. That's it. So yeah, this is the solution and the problem. I'm not going to look into the give blame of who did this because, yeah, finger pointing is bad, and most probably the finger will point right at me, so I'm not looking at it. Let's avoid those things. So, okay, now we have a tool to measure recomposition. Let's actually look at the application under the microscope. What we going to look at today is the playground, so we can play in this part of the application. It's a library. And we're going to look at two server-driven UI screens. If you have never heard about server-driven UI, don't worry. It's not crucial to understand this talk. It's just the way this thing is designed. So I'll give you enough context as we go along so you can understand what the minimum things that are required. And if you want more information at the end of the slides, I have a link. So the first screen that we're going to look at is the one that you are seeing right there. It's a screen with just a column and a list of items, pretty straightforward. And when I measure the layout with the layout inspector this, and also with the frame rate, everything was fine. Scrolling was super smooth. There is no interactions here because this is just static, except for you can scroll, click on something, and then you navigate to another screen, but there is no recomposition going on here. Good news. Okay, cool. Moving on. The second screen was kind of similar, but it has a different thing that caught my attention. Like, okay, here now we are building these text input fields. Don't worry about the UI not being nice, because that was not, the first iteration is about actually building the building blocks and the components. And what I had the theory is like, well, if you type on one of these input texts, nothing else on the screen should update, only the thing that you are updating. So let's test this theory. And we go focus on this specific screen, and we're going to focus on the recomposition on text input field updates. To make this thing a little bit more clear for you, because this is server-driven UI, I'm going to give you a little of overview of how the structure of this screen looks like. So this will be the data structure that comes from your view model, or your typical UI state or view state, however you're going to call this observable thing. And in a normal application, you will have just components, products or something like that. And here you're going to have literally UI components. So the first component, or the definition of a UI component, the first one will be a text title block. So it's just a blob of text. The second thing in this list of this screen will be an input text, surprise, another input text, and what another surprise, another input text. And the last thing of this screen is just a button. So now you know from our view model, it comes this data kind of class with a list of all these 5 components. So we're going to observe this, and when we make changes to one of these input texts, what should happen? Well, I told you this data comes from the view model. It's all data classes, so if anything needs to change, what we're going to do is everything will be copied, because that's the only way to update a data class. You have to make a copy of the data class. And only one string on this whole data structure has to be changed. The rest will be exact copy of it. And what will happen with recomposition? Well, everything recomposes really bad. Let's see it in action. Actually, what you're seeing here is a video of the layout inspector in Android Studio. We expand the tree of Compose view hierarchy, which actually resembles the structure of server-driven UI. You see the 3 text input fields and some other title block thingies. And when we select one and we start typing, then, oh no, look at that. It's like this blue screen of death. Everything is turning blue, and then the counters on the right, you can see that they are all going up. Not just the thing that we are typing, all of them. So everything is recomposing. Everything is updated for no reason. So I don't know. We clearly have a problem here. You see 70-something updates on everything. But what is the problem? Why does it recompose? Everything recompose. And why is it not smart enough to detect what changed and what did not change? So if you look at the blue part that is really nice from the layout inspector. The darker the blue, it means the more updates it's getting, very close in time. So that is kind of our recomposition counter. So our recomposition looks like the amount of updates he's doing in the UI. And so if we had less of those, it will be faster UI, especially when we have too many recompositions on things that should not update. If you have things that should update, like an animation, great, update those. But these other things did not have to update. So those could cause bad performance down the line. But how about the other questions that we had? Why does everything recompose? Why is it not smart enough to detect these changes? Well, I'm glad you asked. Because there is something in Compose called smart recomposition. I didn't invent this name. And it's all based on this concept of stability. Maybe some of you are familiar with stability, maybe not all of you. So let's dig into what is all this thing. So in a nutshell, the smart recomposition is how Compose decides if a parameter of your composable functions, imagine you have a composable function titled with one parameter, if that thing changes. If that thing changes, now if Compose detects correctly that change, it will update the UI to reflect your changes, exactly what you will want to have. And then it's connected to the stability, because stability is how Compose marks your compile code. And then it decides is whether stable or unstable, a class or an object or a parameter of a composable function. So with those markers in the compile code is how in runtime this super smart recomposition system decides if it should update or trigger recomposition. All right, let's dig into these stability rules. Well, the first, let's look at what happens when the class is marked unstable. Let's hope it's the simple one. So when a class is marked unstable, it will get an unstable parameter if you use it in a compose function. So this is the default when Compose doesn't know anything about your class. For example, when there is no annotations, tooling, nothing works. But it's also, in theory, means Compose, if it says a parameter in your composable function that is unstable, it will always recompose when the parent recomposes, either the parent composable or the parent scope. Maybe a good example of this, think you have a title, for example, composable with one parameter that's unstable, and you wrap this thing into a box. If you change the box, and the box needs to recompose because you changed, I don't know, the border or something like that, then your title thing, composable, because it has an unstable parameter, it will recompose, regardless of it changed or not. Those are the rules until here. What else do we have? Well, on the other side, we have stable parameters. What is an unstable parameter? It's something that will skip recomposition when the value doesn't change, which in plain English is when equals is true. Simple, no? So if equals is true, it skips recomposition, otherwise it will trigger recomposition, update the UI, shebang. There is a third thing included in this sauce of stable and unstable, and it's recently introduced less than a year ago or something like that, and is on by default if you're using Kotlin 2.0.20 or newer. That is called strong recomposition. What is a strong recomposition? If you have in mind the rules that I just said, now they added this thing with the strong recomposition that if you're comparing two unstable objects, he will now compare them. Before, it will always recompose, and now it will compare them with equals, 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 which is exactly the same instance in memory. So the address in memory of that object is exactly the same. Regardless, doesn't matter what the content. It could be the same, it could be different. If the address is the same, he will skip recomposition. On the other side, if the address is different, so it's a new object instance, doesn't matter if the content of the object is exactly the same or different, it will cause recomposition. So that's the addition of strong skipping. And so that's that thing that we just said before, and it's part of the documentation of Android, unstable parameters always cause recomposition. Well, in this case now, it's not always, depends on the equality of the object. Also with the strong recomposition came this really nice thing that it was for lambdas, which usually are your click listeners, you will always get a new instance of the lambda that will cause recomposition, blah, 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 blah. There are a lot of articles on the internet saying, wrap all your lambdas with remember. Since a strong recomposition, you don't have to do that because Compose does that for you very smartly. So that's great, no? And now we know how stable and unstable work. But hold on, wait a second. We now know what is stable and unstable, but we have no, sorry, we know the composition counter, but we don't have any idea what is stable and not unstable in what I just showed you before in the application. So how do we measure that? We only have these counters. From these counters, I cannot see what is stable. We actually need another tool, and luckily for us, Compose provides another tool. It's called stability reports in Compose, but they are very raw reports, and they look nothing like what you're seeing on the screen. So they look more like a little bit like this, together with the other files, some of them CSV, some of them TXT, and then you put on top of that all of this, which is really nice to read when you want to go to sleep or have nightmares. So yeah, in our case, we wanted to a different tool, and we went for a one that is producing easy to digest report. So I found this one called Compose Compiler Report HTML. I'm very grateful to the developer that created this tool, and it's very nice because you just simply apply this plugin that you see there, and then just run this nice Gradle command that you see at the bottom, and ta-da, it generates a beautiful report. A report like you saw in the previous screen, but also one like this one. And this one is actually from the code that I showed you before, from our text thingies. So what we are looking at here are composable functions. So you see at the beginning of 24, 25, 26 is a fun navigation back button, fun text input with. And then the other numbers that you see are the parameters. So the first one has 3 parameters, 1, 2, 3. The second one has 1 parameter. And the third one is an overload with 2 parameters with a on-value change lambda. So for the first one, we have a nav controller that is actually unstable, but it's not from us. It's Compose navigation nav controller. It's definitely not a data class, I know for sure. I have no idea how all the complex internals that it has, but yeah. Looks to be unstable. Okay, we need it. I trust you. I'm not going to touch it. But the other thing, the text input is from us. The text input is actually a data class. It should be stable. This is the definition of the text input. It's just an ID. Everything is val. Everything data class is super stable. If you want to change this, you know what you have to do. Copy, and you get a new object that is definitely not equals to the previous one if you change things. So it should be stable. Why? Okay, this looks like our problem, and maybe we can fix this. Maybe this is our first specific thing that we can fix in our application. Haha, we have some concrete actionable item to fix. But why is it marked unstable? And how do we fix this red thingy that I don't like? Well, I really don't know, so maybe we need to find a way to fix these unstable thingies, but the report is just reporting things. So what do we have? So how does Compose actually decide from that thing that you saw before in the report what is stable, what is unstable? It looks pretty random to me. Well, they have something called Annotations and Compiler. Let's look at them. The first one, the first tool that maybe some of you are familiar are called Immutable and Stable. And these are annotations that you can slap in your classes, and then you will tell the compiler and Compose that this thing is either immutable or unstable. The long story short, immutable, it means this thing won't never, ever, ever, forever change, I assure you. And stable is more tricky because it can change, but you are promising to tell every single time, I pre-promise that if I change, I will notify you. So you can even think that your view model, if the only public property of your view model is an observable, you could think that, yeah, if that observable thing can be observed with collect as whatever, it could be named stable. And this is actually how the mutable state from state objects that you see in Compose everywhere, works is stable, not immutable. And we also have the Compose compiler to help us, because we don't want to tag everything with these annotations. So the Compose compiler uses these tags, but how does it infer stability to use these kind of markers? Well, Compose marks a type as immutable if it can never change. If you just hear echo from the previous slide, is the same definition. If it can never change, immutable, cool. And this is something typically you see on integers, string, booleans, long, you name it, primitives. And also on a data class, if you have a data class that only has val variables, or val properties, sorry, then it means the only way to change that thing is to make a copy. You cannot cheat it. If you have bars, okay, that is not immutable. But if you have vals and then nested data classes with more vals all the way, turtles all the way, it is immutable. So the Compose compiler can recognize that. A tricky thing and a bad thing is that the Compose compiler will also think that all your list, sets, things, collection, in general, thanks to Java, are mutable. They are not immutable by default, because the underlying collection backing up the actual data is a mutable thing. So you could do nasty things like create a mutable list and then pass the interface saying, this is a list, and Compose will say, nah, this is mutable. I don't trust you. Okay, so now we are getting somewhere. We have some idea what is stable, what is unstable. We know what annotations we can use, like immutable, unstable. We have an idea of how the Compose compiler works and checking equality with, and also the bars. So now we can go back to our problem and actually try to fix those funky data types. So yeah. Remember that data model that I was showing you for that screen coming from the view model, your view state, whatever? So now I'm going to turn this into the actual compact version of the data models that we use in the application. So this is more or less what you just saw before, but in code. As you can see, there are no bars here. Everything is a val, data class, objects, immutable enums. There are no things that can change here. Everything that is here should change, can only be changed making copies. And that respects what we learned so far from Compose. And everything should be immutable out of the box. Except if you squint your eyes a little bit on the third line below the screen, you see there is a val items, which is a list of column item. Well, that list Compose doesn't trust us and will say it's mutable. I don't trust that it's immutable. Okay, so that's the only thing that Compose, maybe is our only problem that we have to fix. Okay, cool. That will be nice. One more important detail. All of these data models, they are in a separate module of our app because, you know, app architecture, faster build times, clean architecture, you name it. And it's generally a good idea to not put everything in one single file. So what tools do we have now to make this data stable? Well, the first one that we saw is the strongest keeping. We just use a recent version of Kotlin. Well done, cool. The second one is the Compose compiler, which will automatically tag some of our classes. But one caveat there, the Compose compiler only works on the modules where you put the Compose compiler plugin. Remember, I just told you we separate things in different modules for architecture. We could actually put the Compose compiler to all the app modules and all the library modules, but it's like, no separation of concerns. Why do we have UI things in library modules that have nothing to do with UI? Not such a good idea. And also, we could slap annotations again on these classes that you just saw in the tree before. Well, the slide was quite crowded, and it was not the full picture, and there is also data models for presentation and other things. So it will actually require a lot of annotations on everything. So a lot of boilerplate and a lot of tags. And actually, when you're doing this, when you're adding your annotation to your class, you are signing literally a contract with Compose saying that this is stable or immutable. And especially in the case, that's not the case that we saw in our code before, but think of this in your projects. If you slap any of these annotations in something that has a bar or mutable properties or mutable collections or whatever that you're going to mutate, you're actually entering into a contract with Compose. You are saying, okay, we're getting married, and you should fulfill your marital duties forever, or until, yeah, you remove the annotation and you get a divorce. But yeah, I don't know. I'm not here to tell you to stay away from relationships with these annotations, but I know I will. Moving on, what other solutions do we have? The wrapper class. This is one of the oldest ones in this world of stability thingies, and it's pretty simple. You just take a class, you just wrap it with another class, and mark the wrapper as immutable. It's a very simple solution that was around for a while for list, map, collections, things that I discussed before. But it adds boilerplate. I'm going to show you just right now. This is the screen that we had before. Let's fix that list of column items. And now if we, instead of making the items a list of column items, we wrap it with a items collection, for example, class. And then we create this wrapper class with immutable, a data class, blah, blah, blah. I'm even literally running out of just telling this whole boilerplate thingy. But I also think it adds cognitive load, because 3 months, 6 months down the line, a new person joins your team and say, why, when I want to get something from the screen, I have to do screen.items.something. I don't understand. And you will probably have to write a lot of documentation on that immutable items collection data class to explain why are you in your data models including these wrapper things for Compose. Maybe not the best option, especially if you have to do it in all the collections, a lot of wrappers. Alternative, we can have Kotlin X immutable collections. This is from the good fellows of JetBrains. They have this library. It's in alpha forever, so beware. But it has collections that actually respect immutability. But depending if you're using if you already have a code base, it means maybe you have to refactor quite some code. And it looks like this. Instead of having a list, you have an immutable list. Cool. Yeah, thank you. It works. But most of these solutions are for lists and collections, especially the immutable collection of Kotlin X. There is also a relatively new solution. It's a bit older than 1 year old, but it's called the stability configuration file. It's pretty self-explanatory in the title, but it basically marks classes, packages, sub-packages, even you can go into generic parts of generic classes containers as a stable. And the only thing that you have to do is create this text file called blah, 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 conf, whatever you want to call it, and then start adding collections or packages or specific classes there. And also in Gradle, tell the Compose compiler, hey, here is my configuration file. And whenever Compose compiles, it will tag all your code that you define here as a stable, which is great because this is very simple. You see, only one file plus the Gradle thingy. Is module independent. I don't know if we add 20 more modules in the app or we start splitting them, join them, have fun refactor because we want. It doesn't affect this, or you can add things here without actually changing the rest of the structure of your application, which is very good. And finally, there are no code changes, so that's great because, yeah, the Compose should not be affecting with all the things of your code base. A fun fact, do you remember just the immutable Kotlin X classes that we saw in the slide before? Well, they are actually tagged by default inside Compose with the same method. So one of the defaults says, the Kotlin X immutable classes, I trust you, I promise you, they are stable, and Compose believes them to be stable. All right, looks like we have a winner. Let's try to solve both of our problems. One problem we had was the list that was not believed to be immutable. And the other one is our data classes were not being analyzed by the Compose compiler and not believed to be immutable. So, because they were living in separate Gradle modules. So let's try to put all of those in this config file. The first one is the Kotlin collections, and this is pretty opinionated because this actually, before we actually did this change, it was part of how our data flow and the architecture of our app works. We have a unidirectional data flow app, and whenever we change something, we do copies of things. We don't mutate things on the UI or on the presentation layer and then hope that somebody figures out. So what we are saying here, Compose, trust me that I'm doing this okay, is because we were already doing this before. This might vary in your project. If you have mutable lists or sets everywhere and you're doing kind of nasty things, you should be aware of, yeah, with power comes responsibility. But we were already doing this, so that's perfect. For data models, well, you just saw some of them. The list is longer, but all our presentation and domain models, they are completely full of vals, immutable data, everything is copies, copies, copies. So perfect, we just add this double star and everything is there. Since we're here, why not add utility classes? Sometimes in Compose, we need this kind of fibers analytics or New Relic, whatever you have for, which is usually a singleton in your app to report some things. But yeah, it's not stable. So, well, we add it here and now Compose trusts us to be stable. Cool, now we have a solution. Let's now put the theory to practice with the stability report. Remember that unstable text input that was just a data class and it was very red? Now, let's put it in this configuration file like just we did, compile again, and now the configuration and the stability reports is happy. We change the stability, now everything is stable, that we will care about. The text input, we fix it, ole, it's done, yes, yes, we did it. It's fixed, and it's fixed only in one single commit. Just that config file and that Gradle file, we did it. Everything is solved. And also the list, everything is fixed. But wait a minute, I didn't read the whole report. Maybe there was something else in the report. Look at that, that is an unstable view screen reference. For context, this is the kind of thing that we send between navigation in Android. You have to send things between screens, like if you're going to open a product screen or an article screen, you will say it's article number 5. So you will send that 5. So this is that reference. But in server-driven UI, we send not just the article, but it will send the ID of the screen that we are sending plus the parameters. And for the parameters, you can actually think of them like the URL parameters in a query. And actually, the app doesn't care too much about all of this because this is coming from the backend, from server-driven UI. We just pass it to the next screen. We call the backend with these parameters, and we get a new screen. Awesome. So we don't really care too much about all this data. We just pass it around. But for some reason, Compose thinks that this is unstable, and the parameters especially are unstable. Well, the first one, the view screen ID, is just a string, but the other one, the other list, is this thing. And this value byte array, we get it from our gRPC networking client. If you have only ever used JSON and REST APIs in your life, don't worry. Think of this like an efficient binary format for getting a response. It's not too important. But since our app is not really interested in the content or inspecting and using this data, we just pass it around in the original data, which is the most efficient one. It's a binary thing. So as I note, maybe you think this part doesn't really apply to your project because you're not using byte arrays, but the underlying principle of what I'm telling you right now applies to all arrays, but also to any other Java or Kotlin normal classes that are not really like data classes or something like that. So what is the problem with this byte array? I actually went looking into the byte array. Well, if you look at the class, it's a value class. If you're not used to them in Kotlin, basically it's a fake wrapper. It looks like a wrapper, but when the code is compiled, the value class disappears, and it delegates the equals comparison. Remember that Compose requires comparing things with equals. It will forward it to the byte array class. And when I went inside the Kotlin code looking for the byte array class, I found out that it was missing the implementation of equals. So it means basically, yeah, it uses the object equals comparison, not the content of the byte array. Even if in memory I look at two of them and it's exactly the same thing. Okay, let's implement the equals function. How difficult can it be, no? It's just you want to implement them, you have to implement the equals and the hash code function. It's pretty simple. In case you cannot read the message there, I'm going to read it for you because the compiler is screaming at us. Equals is reserved for future releases. Thank you very much, Kotlin. That's really nice that you think of helping me in the future, but I need it actually right now, so I cannot implement it. This is maybe you don't see the red, but you cannot compile this, even if you implement it, because it's reserved for later. Cool, thank you, but no thank you. So it turns out from that safari of stability tools that we just went through a minute ago, there is one option that actually comes very handy here, and that is the wrapper class. So if we write a wrapper class instead of a value class, we could wrap this byte array and implement the equals. So very carefully, we are going to use the wrapper class. Whoop, it switched from value class to data class. I'm going to do it again because subtle data class. That's it. That's the difference. Now we don't have any red squigglies. We can implement the hash code and the equals function. I'm actually not going to do it myself because Android Studio has this really nice function. You right-click on it, and it says, generate code, generate equals and hash code functions for me. Yes, please. And there was no AI involved. This is all coming part of the old-style Android Studio tooling. So great. Well, we just went from the value class to the data class, which is a wrapper, but because now it has an equals implementation, it will not really look inside to the byte array. It will use this equals comparison, and it will actually mark our class as stable. Huzzah! Yes. And now we actually, well, we don't care that the parameter is unstable because the class itself is stable. It will compare with equals, and then it will work. We look at the stability report. Everything is fine. We, well, look at the layout inspector. And now, as you see, when after running everything, the counter went for 120 for the text input field, but the rest of the things are 0, 0, nothing gets blue, everything is awesome. Well, we solved it. Happy ending. It's just one more commit. So, okay, I know. At the end, it was 2 commits, not 1. I lied to you, guilty. But you know what they say. Don't never trust a guy that moves a lot his hands. So let's wrap up. In summary, if you fell asleep through the whole presentation, basically these are the only 3 steps that you have to remember. Measure before actually doing anything, seeing the layout inspector, see the Compose stability reports, whatever is the way that you want to analyze those reports, and then try to fix stability using one of the tools. I think the configuration file is the best one in our case, but maybe your mileage can vary. So you have several tools at your disposal, and then measure again to gain profits. And with that, I want to thank you all for coming.
One of the downsides you listed of the annotations was you're entering a contract with the Compose compiler. Are you not still entering that same contract when you use the configuration file?
Yes, yes. That's why I say, especially if you use bars, yeah, I will not do it. But in our case, I say, because everything is vals and we have this whole tree of immutability and is how we already use the data flow in the application, that contract fits with our already existing model. I didn't have to change any other code. If you have to start adding stable, but yeah, you don't know if some other developer is going to mutate those things, yeah, I think there will be a tricky path forward.
Yeah, I guess so long as the team are all aware that that's a contract you've entered into, because otherwise the annotation is in the same place that you're upholding that contract, which feels perhaps a little neater than sort of a separation of concerns.
Yeah, so the thing is, you are not polluting the code with the tags and writing them, but the final compile code is the same. He knows this thing is marked as stable. It's just shorter one. So the same, I guess your concern is the same principle applies. You should be wary of what you're doing. And that's why I put the disclaimer. Don't just, oh, I have this config file. I can put the whole packages, just put the root of my com.company, and then everything, yeah, everything will fail miserably. Your UI will never, ever update again. Good question.
So how do you make sure a new programmer that joins your team doesn't break this contract unwillingly without knowing it's here. It's on a different file.
Yeah, that's a good question. So in our case, for example, what we do is, well, we have pull requests. That's something that you can always try to enforce the guidelines of your project. There are some tools also that can enforce kind of architectural patterns of things. But mostly in our case, it means all the data models that lives in those modules, which is actually a separate module, only having data models definitions. They don't have actual functions or interface or other thing. In that module, we only have immutable value, data classes with vals. So yeah, if somebody new comes to the team, they should try to stay in the same. If there is a pull request trying to break those things, we'll try to enforce them. We didn't actually document it like a statement on the README, you should do it like this. But we define like the data model should be in this module, follow the pre-existing standards. Yeah.